Okay, so we're going to go over lesson 6.1 and 6.2 within your chapter 6. No. Undo. How do I undo that? Sorry, guys. Just trying to get it so that you can see your title. There we go. So section 6.1 is rational expressions and functions, and then it's going to move into multiplying and dividing. So you can see here a rational function is defined by a quotient of polynomials that has the following form, and the bottom polynomial cannot be equal to 0. So here what we're being asked to do is to find the domain of each rational function using set builder notation and interval notation. Okay. So remember, we just said that we don't want q of x to be 0. So here q of x is equal to x plus 9. And we know from the definition that q of x cannot equal 0. So we say to ourselves, okay, then x plus 9 cannot equal 0. Well, when would x plus 9 equal to 0? That would be whenever x is equal to -9. So how do you answer that? The domain in set builder notation would be x such that x is a real number where x does not equal 9. Okay. And then for interval notation, we would have from -infinity to -9, union with -9 to positive infinity. Because we can be really, really close to -9, but we cannot equal -9. Sorry, I didn't have a freeze up there. My answer in my book, my notebook was wrong. I had to fix it. Okay. All right. So for B, we're looking at a q of x equal to x squared minus 4x minus 5. We're going to go ahead and factor it to make sure it doesn't cancel with the top polynomial. So that would be our x is split, and we want factors of 5 that add or subtract to give us -4. So 1 and 5. We would need a -5 and a +1. So -5 plus 1. That doesn't cancel with the top one. So now we set q of x equal to 0 because it can't be 0. So we need to say, well, when does q of x equal to 0? And that would be at x minus 5 and x plus 1. So add 5, subtract 1. So x equal to 5 can't happen, and x equal to -1. Can't happen. So then we just plug it in. Set builder. Same as before. X such that X is a real number. But X cannot equal 5 or -1. Let's put the -1 first. Interval notation. You're going to have two unions now because you have two options here. So it's going to be from -infinity to -1, union with -1 to 5, union 5 to infinity. Okay. Last one is C. Your Q of X here is 2x² + 1. So when does Q of X equal to 0? Since it can't be equal to 0, that's when 2x² + 1 equal to 0. So we have a couple of options here. We could graph this on Desmos, or, you could do an input-output table. Here's the other thing you can remember. When we talked about one second. Okay, so what you need to remember from last time is that whenever we have a quadratic, remember with the x² term, that means that you're going to have a situation where you have all domain possibilities. So I could solve this to where you can't have an x value, but what you're going to easily see is that you're going to end up having a negative under the square root. So that means you would enter into imaginary units. So that just means that for this answer, and again, it's because we have an x² situation, the set builder is going to be X such that X is a real number. And the interval notation is from -infinity to +infinity. Let's make that a little bit better. And I'll make sure to add the PDF from my professor notes today as well, if I haven't already done so. All right. Fundamental property of rational numbers, that's just telling us that if we multiply top and bottom by some value, that it's the same as multiplying it top and bottom by 1. So it doesn't change the equivalency, but it might help us figure out some information. Okay. All right, so write each rational expression in lowest terms. First thing you have to do is factor each situation. Okay, so we're going to factor the top and bottom. We're going to work with A first. Remember, this is set up as P of X over Q of X. So then we're going to have 3a squared minus 7a plus 2 over a squared plus 2a minus 8. We need factors of 3 times 2, so that's 6. Factors of 6 that add or subtract to give us 7. So we need -1 and a -6. And we're going to do factor by grouping. And then on the bottom, we need factors of 8 that are add or subtract to give us 2. So we can actually go in straight to the split here because this one's easier. So the a split so 8, 1 and 8, 2 and 4. So +4, -2. Should be what it works out to be. Yeah. And then we just going to finalize the top. So we're going to pull out a 3a. Have a minus 2 inside. Pull out a 1. A minus 2 inside. A plus 4. A minus 2. So 3a minus 1. A minus 2. A plus 4. A minus 2. The a minus 2's cancel. So then we're left with a final answer here of 3a minus 1 over a plus 4. And that's it. Okay, so the next one we have to do is, excuse me, B. But I think I definitely have it once more. Do I have another time? No. So what I'm gonna do is C first, and then we'll do B when we have more room. Okay. So for C, you should be able to pick up that we have to do factor by grouping. In the top, we can pull out an M in the front and an N in the back. Same thing on the bottom, M in the front, N in the back. And then you should notice here that the M plus N's cancel. And you're going to be left with A minus B over A plus B. Now we can't do anything like pulling out a 1 or anything like that because you're just going to constantly do it all day long. You're not going to be able to isolate that any further. All right. And then I actually think I can get B in here as well, and I'll just get rid of the extra slide. So here you need to recognize that this is a sum of cubes. So then X is equal to T and Y is equal to 2. We get 2 because the cubed root of 8 is 2. So then you have to remember back to your formula, which is x plus y times x squared minus xy plus y squared. So let's go ahead and shove this all in here. We're going to end up with t plus 2 t squared minus 2t plus 4 over t plus 2. T plus 2's are going to cancel. So your answer here is just going to be t squared minus 2t plus 4. And you can't FOIL that or factor that because you're only going to have 1 and 4 and 2 and 2, and that doesn't help you. So that's it. That's your answer there. So let me go ahead and get rid of this one for you. All right. So here they're just telling us that we can, if we wanted, we could use this idea of pulling out a -1. So then you can cancel. So let's take a look. Here for A, we have A minus 10 on top. If we pull a -1 out, then we would have -10 plus A. So if we rewrite it and put the A in the front, you can see that we have the same expression here, or binomial rather. So then they're going to end up canceling, and we would end up having 1 over -1, which is just -1. Okay. And we're going to go Christmas on this slide. So remember, this is considered a difference of 2 squares. Guess I should write that a little nicer for you. So to do that, what I would do is just pull the -1 out now at the top. So if we pull a -1 out of the top, you're going to get -81 plus y squared over y minus 9. And if we rewrite that, then we get -1 out front, y squared minus 81. That's still a difference of squares. And then we have -1 out front, and then we're going to split it y and plus 9 minus 9 over y minus 9. You're going to see that the y minus 9's cancel. So you're going to be left with -1 y plus 9. So you could leave it written as -y plus 9 inside, or you could distribute it and get -y minus 9. Either option is correct. Doesn't matter to me which one you end up using. Okay, let's keep going. All this is telling us is that if we have a situation where we're multiplying, we want to factor everything completely and then multiply like normal and check if it's in lowest terms. Okay, we have to get all this on this page, and that's fine. We can do that. All right, let's look at this one. So what I like to do is, even though it looks kind of simple, I like to go ahead and factor each piece first, even if it looks kind of like a no-brainer as to what I'm factoring out. Oops. Like see here with the 8t times t and the 9 times t, those are pretty simple looking, but I mean, it still helps you see it. Remember, this is a difference of squares. So then you split the variable and then it's just plus or minus whatever the square root is. Okay, so the t's cancel here, the t plus 2 cancel here, and the 3 goes into 9 3 times. So your answer here is 8t on top. Sorry, I was just double checking something. And then 3t minus 2 on the bottom. Right. Next one, we're going to have to do some more factoring. So for this first spot, you need factors of 15 that'll add or subtract to give you a 2. So we're going to use 3 and 5. You need a positive 5 and a negative 3. So that'll be m plus 5 and m minus 3. Okay. For the next piece, we'll do it in this color. We need factors of 6 that add or subtract to give you 5. So we'll need a negative 3 and a negative 2. That's what works here. So minus m minus 3 and m minus 2. Okay, and then we'll use another color. Again, we have a difference of squares. So you're gonna do a splitting of the variables and then a plus minus of the square root. Okay, and then the last one, all we have to do is factor out a greatest common factor. Okay, and now we can start canceling some stuff out. So the m minus 2's cancel, the m plus 5's cancel, the m minus 3's cancel, and we're left with, oh, sorry guys, decided to go away on me. We're going to be left with m plus 2 over m. And that's it. Last piece I'm going to show you is how to divide, and then we'll come back for section 6.2 in a second video. So dividing is pretty similar to multiplying. You want to divide a fraction by multiplying by its reciprocal. Okay, so we'll do a first. And what I'm going to do is factor and flip at the same time. So here we would technically have 4k times 4k over 5. We're going to multiply by our reciprocal. So 10 is going to be on top now, and 3k is going to be on the bottom. 5 goes into 10 twice. 1k gets canceled. 2 times 4 times 4 is 2 times 16, which is 32k over 3. Yes. Done on that. Now, what you're going to notice with the next one is we have to do a lot more factoring. Okay. So let's do this one in this color. So 3 3 times 2 will give us 6. We need factors of 6 that will add or subtract to get us 5 in the middle. Oops. Oh, gonna have to do that thing where I stop screen sharing and then re-screen share. Mhm. Okay, guys, I'm not really sure what's going on. All right, there, it worked. What we want to use for the first one is actually going to be 1 and 6. If you work it out, it actually doesn't work with 2 and 3, so just be careful. If it doesn't work, you can always go back and try a different set of factors. Sometimes it'll work and sometimes it won't, so just be careful that you're picking the right ones. So we're going to end up pulling out 3k here, and we get k minus 1. And we'll pull out a 3 and get k, or pull out a 2 and get k minus 1. 3k, 3k. Okay. So then we end up with 3k minus 1 on top, k plus 2. And then for the next one, this is a difference of 2 squares again. So again, you're going to do, here we have to remember that the square root of 9k squared is 3k. So we split that root. And then we also do a plus minus of the number. Okay. I'm going to go ahead and do the factoring first, and then I'll take the reciprocal. So for this one here, we just have to pull out a GCF. It's actually a GCF for both. So, but the GCF here is 4k. So if we pull out 4k, we'll have 4, nope, just k, k plus 2. Okay. And then the last piece, this one's another GCF. It's a GCF of k. So we're going to pull out a k, and it'll be k minus 7. Okay. Let's rewrite each piece. 3k minus 1. And then 3k plus 1, 3k minus 1. I forgot the k plus 2. Now we're going to multiply by our reciprocal. So k minus 7 will be on top. And 4k, k plus 2 will be on the bottom. Now we can do our canceling. The k plus 2 cancels, the k cancels, the 3k minus 1 cancels, and we're left with k minus 7 on top. Let's write that a little bit better. And 3k plus 1 on the bottom. All right. We will pick up with the next section on a later video. All right. Thanks, guys. See you soon.